Welcome to the Real Python Podcast. This is episode 139. Have you embraced the use of comprehensions in your Python journey? Are you familiar with all the varieties of comprehension constructs? This week on the show, Christopher Trudeau is here, bringing another batch of PyCoder's weekly articles and projects. We discuss a recent article that surveys Python's comprehensions and generators. This overview includes code snippets and the fundamentals of creating list, set, and dictionary comprehensions. We weigh the advantages of using a comprehension versus the more familiar for loops that they replace. Christopher shares an article about how there may be infighting between parallelism in your Python code and within the libraries you're using. These complex system interactions can cause sluggish processing slowdowns and hard-to-trace bottlenecks. We share several other articles and projects from the Python community, including a news roundup, a Python Linter comparison, multiprocessing race conditions in Python, a discussion covering import statement styles, a project for WebAssembly-powered Jupyter tools running in the browser, and a collection of Easter eggs and hidden jokes inside Python itself. The InfluxDB time series platform empowers developers and organizations to build real-time IoT, analytics, and cloud applications with timestamp data. Learn more and start for free at influxdata.com. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Happy New Year.
Yeah, it's kind of wild to think about. Had a really interesting episode where we wrapped up all of last year's articles and projects, and your name came up a few times. So,
And none of you should believe anything they said.
Sure. So I thought we could start the year with a little bit of news lingering from the end of 2022. You had a few releases. Actually, I think they're all releases.
Yeah, it's just some release notes. With the holiday gap, by the time this goes to air, this news is a little dated, but in case we're the only place you get that kind of stuff, I figured I could spit it out quickly.
Yeah.
We'll debate whether or not it's quickly. We'll get there. So first off, PyPy, that's the interpreter rather than PyPy, the package site. Naming is hard. They had a release which was 7.3.10, and it's out. It includes some performance improvements, some bug fixes, and the addition of support for the Apple M1 chip.
Oh, great.
Django, the framework, rather than the slave movie, released 4.1.4. Also a bug fix release addressing a couple of different crashes that happen inside of the ORM. And finally, CPython, the interpreter, rather than the swimming snake, I just had to do the rule of threes on that joke, has released fixes for all the supported versions. So that's 3.11.1, 3.10.9, 3.9.16, 3.8.16, 3.7.16. These releases address a couple of bugs and some security gotchas. And additionally, the 3.12 release is now in Alpha 3. So if you haven't already, go forth and patch.
This first one of the topics that we were going to dive into today, Alistair Weigart, frequent guest on the show, has a Python Linter comparison article. It's dated, 2022. It's funny because it's a very long title. It's basically all the names of these things back to back. PyLint versus PyFlakes versus Flake8 versus Pep or AutoPep 8 versus Bandit versus Prospector versus PyLlama versus Pyroma versus Black versus MyPy versus Radon versus Macabre. And honestly, they're all different. They're all different types of things. And that is probably my favorite thing about it, is that this article that he wrote is his dive into looking for a new set of tools, or at least an updated set of tools, when he decided to upgrade his text editor. He uses Sublime, and so he went to Sublime Text 4. He actually is using Python 3.12, which I thought was interesting, but I guess as an author, that's not bad to be ahead of the game. And finding things. But he lists right away the ones that he selected, which are PyFlakes, MyPy, and Black. But then he mentions all these other ones and kind of went through a big list. And one of the things he does is he created these sort of categories, which is type checkers, which basically are verifying that your program's following correct types of type annotations, aka type hints. And so that would be things that we've talked about on the show quite a bit of Pyrite, MyPy. And there's a couple that I haven't used, Pyre, Pyre, and then PyType. And then he gets into error linters, which are very different. And those are really diving into syntax errors and looking at unhandled exceptions and potential crashes. The one that he had picked out of that is PyFlakes. And I think that's the one that you use, right, Christopher?
Yeah, PyFlake, of this list, I use PyFlakes and Black personally.
Yeah, okay. And the one that a lot of people at Real Python use is Flake 8, which actually goes beyond, it actually imports PyFlakes and then two other things. It adds PyCode style and this thing called Macabre, which I'll get to, so it just sort of goes on top of what's linting. And I think that's the reason why you like just using PyFlakes, is it's a little more less opinionated.
Yeah, it's I find because most of the coding I do is just for me. I'm not trying to tie things into like a big CI/CD pipeline.
Yeah.
I'm using the linter primarily for two things. One, if I've written a whole bunch of code without testing, like if I've sat down and written a couple hundred lines, I find it's often faster to run the linter to, check for the, hey, you're missing a comma here kind of stupidity than it is to actually run the code. And then I often do it as a cleanup step before I commit, so that I, look for imports that I don't use from copy and pastes and things like that. Over the years, I haven't experimented with anything recently. I just found when originally went looking for tools that Flake 8 there were too many things it wanted that I didn't feel like doing. So PyFlakes was just a nice compromise.
Yeah, it seems to be that way for, a variety of people that I've talked to over time. And then we had that long discussion a couple weeks back where we were talking about the idea of using a linter and it finding, lots of problems in your code as opposed to running your code and finding one at a time. So that was kind of one thing you could look back. The next area that he dives into is the style linter, which is kind of what, say, Flake 8 and another one called PyLint. They start to look at the Python's PEP8 document and start to figure out where stylistically are you following the sort of guidelines of PEP8. He's got a couple that I have never played with. Packaging linters, which look at issues that could be related to distribution of your code. That's this one called Pyroma. Security linter, which looks for potential security vulnerabilities. He talks about that later in the article, going in deeper. It's this one called Bandit. And most often, if you're not using lots of outside packages or you're not creating like web frameworks and things like that, it may find really simple stuff. It isn't going to find a whole ton of security flaws like that could be potentially problematic. And then these code formatters, or just sort of the ones that we've always talked about as Black, the idea that's going to kind of enforce a very specific style about white space in your program. And then a complexity analyzer were the last kind of things that he gets into. That's this thing called Macabre or Radon. And I had a big, long conversation about refactoring your code with a couple people from Sorcery. And we were discussing this idea of cyclomatic complexity, and it has this thing called Halstead metrics that Macabre does the cyclomatic complexity. And then one called Radon actually goes in and runs what are called Halstead metrics that are based upon the numbers of operators and operands to calculate the difficulty of understanding the code. So a couple tools that, along with some of the ones that I mentioned in that previous podcast, which I'll include a link to that episode so you can kind of check it out if you're interested in learning a little bit about tools to study the complexity of your code. But it's a nice survey. I'm glad he did it. I think it's nice to kind of see somebody's opinion about these different things and then go through the process of sort of auditing them. And then he did find a few that are sort of, I guess you would say, no longer being updated. Oh, the one thing that I thought was interesting is, have you ever used a dead code linter?
Not in Python.
Okay.
I've used similar tools in other programming languages.
Yeah, the idea is that, let's say you're writing your code and you're going along and it's fairly long and you've done some experimenting with the tried and true, hey, let's comment out part of this code and see if it runs better with this new code or vice versa. And this would actually find those sort of unused things that you were doing inside there, or potentially finding unused imports or other types of dead code.
They're often looking for like unreachable code.
Okay, that too.
Say you've got like a long function and you return in the middle of it, and you meant to come back and clean up, but the code underneath that return, you can't get to it. These kinds of linters will flag that stuff for you.
Yeah, so it's kind of doing the whole tree thing that we've talked a lot about, the idea of building a AST and kind of looking through everything and making sure that, hey, is this actually functioning and running in
functions that aren't called, that kind of stuff as well.
Yeah. And then I think the one last one was, we had mentioned this a couple times, and we'll be talking a little bit more later about this, import statements. And there's a tool called isort, which sort of sorts your imports in an alphabetical way to kind of organize how your imports look.
Why would you need a tool for that? You don't just do that naturally when you code?
Maybe not. I have seen some really interesting styles of imports. So
our degrees of anal retention are probably significantly different. Yes.
That could be possible. Yeah. It's a nice read. And if you're not aware of Al Swiggart's books and other tools, his Invent with Python blog has links to all the different things that he does. And a lot of his books are free to read on the web. And obviously you can also buy them. He has a whole bunch of them for sale. All right. So what's your first one?
My first article is from a name that shows up frequently in the PyCoder's newsletter. It's Itamar Turner-Trauring, and it's entitled Who Controls Parallelism? A Disagreement That Leads to Slower Code. The article is about the state your code can get in when both you and your libraries are doing concurrent programming. The example that he deconstructs is one with a thread pool and the NumPy library. When he ran the code in a single thread, it took 1.2 seconds. Then he tried a thread pool version, which took 1.5 seconds, which is the wrong direction. And then switching to multiprocessing mode, it goes up to 2.2 seconds, which is even worse. He's running this on a 12-core machine. And so if the problem were the GIL, the multiprocessing would have fixed it. But evidently, that's not the problem. So then now for the deep dive. NumPy uses a library called OpenBLAS, which is an implementation of the BLAS library. And yeah, that didn't help me either. I had to look it up. BLAS stands for Basic Linear Algebra Subprograms, and it's an interface definition for doing linear algebra.
Okay.
It defines functions for vector and matrix operations, and there's a bunch of different implementations. So this is one that NumPy uses underneath. And the slowdown here is a side effect of what NumPy and OpenBLAS are doing. The single-threaded program that I mentioned, well, Itamar started to debug the problem, and he discovered that it actually had 20 threads. The thread pool version had 43 threads, and the multiprocessing version had 401. And this is all because OpenBLAS itself is creating thread pools, and hence the title of the article. So the Python threading is fighting with the OpenBLAS threading, causing unpredictable performance problems. In the threaded version, essentially the thread pool and the OpenBLAS thread pool are both creating queues. And with a single Python thread, it feeds OpenBLAS and its queue, and OpenBLAS goes and does its work. With the multiple Python threads, each of those threads ends up feeding the same OpenBLAS queue, and they start fighting to feed that queue. And then OpenBLAS has its own queues, and this is what is slowing the program down. The multiprocessing version is a little more complicated because you should end up with a single queue in that version. But Itamar suspects that the memory caching at this point starts getting overwritten, giving the single-threaded version a performance advantage. So what can you learn from this? Well, one, concurrent programming is hard.
Yes.
Two, in the OpenBLAS case at least, there is an environment variable you can set to control how it threads. This can give you the fine-grained control on where the threading is happening. You can decide to do it in your code or in the library. that solution might not be available with other libraries where similar conflicts can occur. You can still gain some speed advantages by deciding where your parallelism happens, essentially just avoiding that fight that I was talking about.
Yeah.
So you could do data loading or pre-processing concurrently, as long as when you call the library in question, you design a bottleneck, right? You need a join place before you hand it off to avoid the fight. So it's a great article showing the hairiness of concurrency and how sometimes you have to understand what's going on under the hood in order to, get performant code, even though, throwing more threads at it doesn't solve the problem is often the challenge.
Yeah. The assumption that the hardware is going to just solve everything for you also.
Yeah. I remember at one of the companies I was at, I brought Python to the company. It was a small startup. I was working with an ML guy, and he was like, "Oh, this is a neat language. I like this. This is great." And it lasted about 2 weeks, and then I got this phone call, and he was just irate. And it was because he had discovered the GIL. And you kind of have to know what you're doing.
Yeah, yeah. Yeah, there'd be some dragons there.
Yes. Multi-fanged, double-headed dragons, I think. Yes.
Yeah, totally. Are you building real-time applications? Check out InfluxDB, time series platform. InfluxDB is optimized for developer productivity, so developers can build IoT, analytics, and cloud applications quickly and at scale. With its data collectors and scripting languages, a common API across the entire platform, and highly performant time series engine and storage, InfluxDB makes it easy to build once and deploy across multiple products and environments, at the edge, on-prem, or in the cloud. Check it out and start for free at influxdata.com. That's INFLUXDATA.com. My next one is kind of a nice short read. I really enjoyed it. It's by Pete Feisen. It's on Medium, published in a blog called Towards Dev, titled A Crash Course in Python Comprehensions and Generators, and the subtitle is Master Them in 20 Minutes, Use Them Every Day. If you're not familiar with list comprehensions, then boy, oh boy, here's a really great secret for you to save a lot of effort and a lot of writing, and some really neat tricks that are inside Python for you. And then also along the way to learn about the concepts of generators. He does a really simple introduction to them. So I've also included some links if you would like to dive deeper into generators. But comprehensions take what could be like 5 lines of Python and combine it into a single line. The idea very often of creating a list and then appending items into it is something that it is kind of doing automatically for you. The hardest part of a list comprehension is sort of remembering stylistically how they're written. And he has a whole area of the article where he talks about that and why to kind of practice them and get in the habit of writing them. I like something that was in one of our articles about it, in the idea of list comprehensions, where you have, say, the name new list at the beginning of the line that you're creating as an object, and then you're assigning with the equal sign. And then inside of a pair of square brackets, the usual list notation things, it starts with an expression. And that expression could just be the item that you want to get out of, say, an iterable. So it could be, I or something like that. And then you start a for loop right after that. So you say for member in iterable. And if you can kind of remember the style, and it helps to kind of look at the article and get an idea of it, but it's very much like a for loop that's been sort of folded together out of like a couple lines. There's no indentation, there's no colons. You don't have to create the whole empty list. It's very Pythonic and kind of clean and ready to go. A generator changes the square brackets into the regular parentheses, rounded brackets that everybody's used to seeing on normal speech. So it looks a little more like you sort of setting aside an expression or something like that. But it's the same format. And then what's cool about generators is that they have this really great trick where they're lazy. So they basically don't evaluate what's inside them until when they're actually needed. And so it can improve speed of your code. It can also minimize memory use and allow you to do lots of interesting things, especially if you're working with big files or large chunks of data. But they look identical. They just change the outer brackets on them. And he also talks about set comprehensions. In that case, you're using the curly braces. And if you're not familiar with a set, basically you don't have any repeating elements inside of a set. And then the last areas he kind of gets into is he talks a little bit about dictionary comprehensions. And the difference is at the front, the expression you'll see will have that sort of dictionary style of key : value before the for statement in it. And he talks about some common things like you might see as a common interview question, the idea of flattening out values that are in a nested comprehension. He talks about how to do that. It looks a little kind of crazy inside a nested list comprehension, but he has a nice graphic to kind of show what's happening inside there. I liked how he did that. He talks about this idea of eggs inside of nests inside of trees, which I think is not a bad way of explaining it. And he has this little graphic kind of take you through it. And then the last thing he talks about is this idea that if you want to take an expression, in this case, say a list comprehension, if you would like to have it be filtered, you can have that conditional statement at the very, very tail of what's happening. So you'd have expression for member in iterable, and then if conditional, kind of all in a line there. He has some nice notes at the very end talking about sort of testing your mastery, and he adds a few challenges for you. So again, a quick 20 minutes, you can dive in and learn some of these concepts and then come back and practice them. And if you want some more detail, I'll include links for deeper articles on Real Python about how to use generators and yield inside of Python. And then I had a great conversation in episode 39. I talked to Reuven Lerner, and we had a long conversation about how generators work and sort of the concept of coroutines and his style of learning Python through exercises. So might be a nice way to dive in a little deeper on the topic also.
And speaking of that, I find if you're thinking of picking up some of the async IO stuff, because it uses similar structures,
yeah,
I find that generators, at least for me, were easier to understand than some of the async IO pieces.
Okay.
So if you were going to dig in, you might find value in going and learning a bit about the generators and getting comfortable with the yield in a single-threaded application before you go and make it complicated by multi-threading it.
Yeah. Yeah, and this really is just this real initial, like, kind of just talking about how they're written. It doesn't really give as many good examples of like, well, where do you use this and how is this useful to you? And so I thought I would include the context for that.
Yeah, for sure.
Because that it becomes a little more vital.
Yeah, and the other aspect, I don't think gets into it in the article, but comprehensions 90% of the time are faster than the equivalent for loop.
Yeah.
Because the intermediate variables that you have in the for loop aren't needed. And so the process of loading those into the stack and playing with them and all that gets eliminated. So they generally are faster. But they also tend to be a place where fancy coders go and make things unreadable.
Yeah.
I love that he's got a great analogy for nested comprehensions, but my gut reaction to that is don't do it. It starts to become really hard to read really quickly.
Yeah. The two for loops is much easier to read for that. Yeah. And I could kind of see it though as it is a nice way to break apart if you do have lists inside of lists, if you need to flatten them, which isn't fairly, I don't know. It's a common thing that I've seen.
Yeah.
And it's especially a common interview question, but presenting it as this fancy list comprehension or nested list comprehension might be a little confusing. So yeah, it gets into that complexity level.
I generally find if I can keep the comprehension on one line, it should be a comprehension. If it starts to sneak onto two, there's like, okay, maybe. By the time it hits three, it should be a for loop because it just becomes too messy.
Yeah.
But, that's just a rule of thumb.
Make sure you keep readability in mind. Yeah. Kind of continuing on the theme from your previous article, you have another.
Yeah. I've got a theme going for sure. This article is also on concurrency. It's called Multiprocessing Race Conditions in Python, and it's by Jason Brownlee. Jason's the key contributor to superfastpython.com, a site that is a really solid resource for learning concurrent programming in Python. The article starts out with a definition quoted from the Art of Concurrency book, defining what a race condition is. And it goes like this: a flaw in a concurrent application in which the result is dependent on the timing or sequence of multiple threads' execution. So, for example, a common cause of race conditions is shared data. 2 or more threads try to update something at the same time, causing an incorrect answer. And this can get really sneaky. You have to remember that Python is actually an abstraction of bytecode, and a single line of Python will likely result in multiple lines of bytecode. And so even when you think you're doing one thing, you might be doing several things in a row. So let's say you're adding 5 to a variable. If 2 threads both do this correctly, you should get 10 more than you originally had, right? So adding 5 breaks down into load the variable into memory, add 5, then overwrite the variable with the result. And what can go wrong here is if one thread loads the value and adds 5, and then thread 2 takes over, loading the value, when the first thread writes it, the second thread will do the same and overwrite it, and you'll end up with 5 more instead of 10 more. So this is a classic data style race condition. And then another common problem is just straight timing issues. The OS is responsible for when threads execute, and it can swap them whenever it feels like it. So let's say thread 1 is supposed to open a database connection that's shared, but thread 2 happens to execute first. You're going to get a connection not found, whatever kind of error, right? So that's just like a straight timing thing. So the article gives a few examples of both of these kinds of cases, as well as showing you ways to get around them. So far, I've been talking about threads, but similar challenges exist with multiprocessing as well. And the article goes on to show the same kinds of content in the multiprocessing case and how the answers are subtly different. There's similar themes to them, but the approaches are different because they're different libraries. There are loads of details. It's a pretty comprehensive article, and it shows you how to use process locks to ensure that only one thing happens at a time. Shows you how to use process managers as well as custom classes to encapsulate the kind of code you need to deal with. So there's lots of depth here. Also uses the condition class from the multiprocessing library that has a wait notify structure, allowing you to communicate across your processes and sync up your actions. So like I said, big deep dive into multiprocessing here with fixing race conditions as well as sort of the running theme. And there's a lot of good links to other sources of info here as well. So if you're wanting to dive deep into the multiprocessing thing, this is a good place to go.
Lots of keywords to practice
Yes,
as you're getting into them. Yeah. Yeah, he looks like he has a ton of resources included and lots of other further reading stuff. So
the site is full. We often go to him for stuff inside of PyCoder. So it's a lot of great content in it.
Yeah, lots of regulars this time. That's great. This week, I want to shine a spotlight on another Real Python video course, and it goes along with another one of the articles this week. It's titled Understanding Python List Comprehensions. The course is based on a Real Python article by James Timmons. And in the video course, Rich Bibby takes you through how to rewrite loops and map calls as a list comprehension in Python, choose between comprehensions, loops, and map calls, supercharge your comprehensions with conditional logic, and how to use comprehensions to replace filter. I think it's a worthy investment of your time to learn one of Python's most distinctive features and how you can use them to create powerful functionality within a single line of code. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All our video lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. That takes us into our discussion, huh? The discussion this week is from Twitter, and hopefully it'll be alive when you come to check it out.
There's a delay between recording and release.
It's been some...
Heaven only knows what's happened in the meantime, yes.
Yeah, there's been some real weird stuff in the last couple of days. So it's from Bob Belderboss, and he works on PyBytes. He wrote a very short tweet basically asking a simple question of how do you use imports in Python? And wrote, do you import like he uses pathlib as an example. So he says, okay, is the statement just import pathlib, where you would still need to type pathlib.path to use the different methods and things that are inside that? Or do you type it out as from pathlib import just path? Maybe you just need path out of pathlib. And that way you can just write path and then use it. And then he asks why, and got pretty good answers from some of our usual friends, one being Stephen Gruppetta. He answered almost always import the module to have separate namespaces. And this is the theme that I keep seeing often in here. Namespaces are one honking great idea, which is from the Zen of Python. If you haven't done import this. There are a few examples of people who are from the data science space that use an alias. So saying import pandas as PD or import numpy as NP. And partly if you've done a lot of, you're going to use that module quite a bit, it's nice to have, the namespacing, but it's also sometimes nice to have an abbreviated name for that namespace. And so that allows for that. And so there's just a whole bunch of different things in here. And I thought we could discuss it. Chris had found this thread and I was like, okay, yeah. And it also kind of brings in, and I have some additional resources. If one of the ones actually quite a bit is a site that is called Python Anti-Patterns. And it has a bunch of reasons why you shouldn't do them. And one common one is the from pathlib import star, which imports everything and sort of dumps it into the namespace and why that's bad. And so anyway, we can just discuss a bit. What were some of the things that you wanted to talk about?
So the import star I don't do. I don't think I've ever done it in Python. I think that was beat out of me in my Java days because it has a similar sort of structure, and that was common thing at the same time is do not, all that extra crap in memory, don't do it. So that one I've never done. I started to kind of think about it when you asked the question, and I realized I think I'm consistent, but I don't know if someone who wasn't me looked at my code would agree that I was consistent.
I'm consistent to myself.
There's a pattern. Like I'm. It's not like I changed my mind, but a lot of it kind of depends on. For me, it's a clarity thing, right? So
sure.
So for example, pathlib I use all the time. So I'm not going to namespace that. If I see capital P path in my code, I know what it is. So I'm not going to bother namespacing it. I'm going to bolt the path object in directly.
And that's not a super common collision, right?
No. And I guess that's where there's always exceptions, is if there are places where there are going to be collisions, then, I move towards using the namespacing.
Yeah.
I think if I were to go through and list out, I don't know how I could create a style guide based on what I do. It would be horrible, I think. But like third-party libraries that I don't use as often probably get namespaced.
Okay.
Because then when I'm reading my code, it's like, it's
where did this come from? Yeah.
Even in the standard library, right? Like you're sort of, I think if I'm doing something in math, I probably import math rather than just import sine or cosine, for example.
Okay.
But then some of it is context-based. So, we've talked before about, I do a bunch of stuff with Django Ninja. And usually when you're coding something like that, that's a REST API library. Most of the code ends up in one file in Django, and it's usually called api.py. So why do I need the extra namespacing? I just grab what I need from Ninja because it's all ever going to be in there. And then the flip side of it is in Django, when you register your routes, you have to bring in the views.
Yeah.
And because of the way Django is structured, all the views tend to be in a file called views.py. They're in different modules, but they're all called views.py. So when you're bringing those in, that gets really confusing. So that's where you get into the aliasing. So I frequently do things like from books imports views as like book_views, for example. So
okay.
I suspect if I ever go back to coding with large teams, I'm going to be violating code formatting norms and getting yelled at. But
you'll get some notes.
for my own little open source libraries and my own projects, it's like, all right, fine. It's, I do what makes me happy. How about you? Do you have habits? Are you consistent?
So I was, I learned Python on the fly at a job. And so I followed lots of tutorials and I was watching other people do certain things. And I did see that anti-pattern of import star a lot. And I was like, okay. And then I had to think to myself, and this is actually one of the first courses that I did for real Python, was on importing modules and stuff. And it really helped to see if you will, the wreckage that you're creating in namespaces by using the command dir and a couple brackets, the built-in command that shows you the directory and the namespaces. And you can very quickly see like, oh, I've, just before you do anything, just type dir and see what it looks like. Then run your imports, like say in a REPL session, and you can see how all this sort of builds up inside there, and how what you thought would be a simple import has now, polluted the whole namespace with all these different things. And you have to avoid using any of those names. And then programming ends up doing common things, and I think that's also a reason why modules probably shouldn't all be named utils, and things like that. So that, if you're importing utils from a couple different places, that it can get kind of crazy. So that's a practice that I kind of learned very early on. And having done a lot of data science, I've done the aliasing thing quite a bit with the PD for pandas or matplotlib. I was probably using, I know NumPy, a lot of people use NP. So that's the place
Yeah, PD and NP are really common. I see it all the time. Yeah.
Yeah, because I think it's just typing them out. They're kind of funky words to, make sure that you pluralize and so forth. So it was interesting to kind of see different thinking. I agree with the, keeping the namespaces. One thing about importing just individual components, if you will, individual
objects. Everything in Python is an object. You call it an object and you're not wrong ever.
Yeah, true.
And people don't get all cranky because you called a method a function and a function a method, even though they knew exactly what you were talking about.
Yes, they really get upset.
Welcome to the internet. But pedantics are us.
But it is a function. It's just, where does it live and where is it called from? So yeah, I do see a lot of people import just lots of little piecemeal things. And I think it's all sort of a stylistic thing, but I definitely agree with, if it's possible to keep the namespaces kind of clean and, kind of pay attention to what you're doing, it's not a bad habit to import the whole module or to alias it. So cool. Well, that brings us into projects. All right, I'll go first. So my project is following along in our WASM future here of WebAssembly and Python and PyIodide and all these other kind of fun things happen. It's called JupyterLite, Lite. The Jupyter is the typical Jupyter. And it's by a bunch of people that work on the Jupyter project themselves. It's a Jupyter Lab distribution that runs entirely in the browser, built from the ground up using Jupyter Lab components and extensions. And it's definitely a work in progress. The status is it is currently being developed by core developers from the Jupyter team, but it's still kind of an unofficial project. So it's kind of in a neat state that if you want to come and play with it, you can. They have a really neat demo site for you to try out. And I did. I like the logo. It's like a little light bulb, JupyterLite, with a kind of as the wires and a cursive thing. And I was able to just, kind of play inside of it. And the idea is that you could set up a site for yourself very easily, because it's very much like setting up a static website, which is pretty cool. You could do it locally, or you could do it with a static web host. You could embed it in a larger application. It doesn't require a dedicated application server or like containers or Docker and all these kinds of things that you would think of that you would need. And there's lots of services that do Jupyter stuff, but it's kind of cool that you could own it, and have it all set up on your own and have kind of control over it. This was a thing that would have been really handy in the sort of intranet that I was working with at a bank or a law firm, where everything was very closed down. But if I wanted to have the ability to show something to somebody and have it be interactive, this would have been a really kind of handy tool. And we've talked about a few other deployment tools, but a lot of people are very comfortable working inside of notebooks, and this is a neat way to do that. There's a sort of ease of development to it and deployment of it. They actually in the documentation show deployment options for deploying to GitHub pages, read the docs, GitLab pages, Binder, I think we've mentioned before, and two that I'm less familiar with, Vercel and Netlify. And then they have a really nice set of showcase sort of visualizations running at the bottom of the main GitHub page. They have it showing Jupyter interactive widgets that we've talked about a little bit, the IPy widgets thing. It running matplotlib and Altair and Plotly, which I think are included as tools ready to go kind of out of the box. And they mainly show it working as the Jupyter Lab version, but they have a thing called Retro Lab, which seems a little more like a standard Jupyter notebook style, a little less of the integration of the files and things like that you see inside of a Jupyter Lab. I just think it's a really cool project. It's got nice documentation, lots of examples. They show it running these code consoles. I think it's just a nice project to kind of keep an eye on. It's one of the latest sort of WebAssembly pyodide things that I'm intrigued and to see where it goes. And I think it could be a really handy tool for self-hosting Jupyter stuff and not necessarily needing a whole lot of infrastructure to do it. So what's your project?
So this is really not quite a project. It was in our projects list in the newsletter, but it's just a little bit of humor, a nice, light, sort of joyful thing to start the year with.
Here you go.
It's a collection of Easter eggs and hidden jokes in and around Python. The collector in this case is Himanshu Mishra, and he's posted it to a GitHub README. The list starts out with one I hadn't seen before, which is import dunder hello.
Yeah, I've never seen that.
Yes, evidently Python has a built-in hello world. That's batteries included. And there's a variation on it, which is dunder p hello, which is the case-insensitive version of it. So they're both there.
So import fellow.
Yeah, exactly. A common one that a lot of folks know is import this, which recites the Zen of Python. You may recall part of that is there should be one and preferably only one obvious way to do it, which of course is a counter to dunder hello. Hello world, anyone? Speaking of the Zen of Python, item number 8 on this list shows you how the Zen is coded. For some reason, they decided to rot13 encode it. So the import is actually running a short decoding script before presenting the results. So weird. Somebody had a little too much time on their hands, I think, or didn't want it greppable or something.
Yeah, it's definitely, they said their note on the bottom there. It's not beautiful, but ugly.
Yeah, exactly. It's hideous. And I think one of my favorites, so if you've ever come across import dunder future, this is a tool that you can use to get changes from future releases further up the release chain into your code. A real example, this is from dunder future import print inside of Python 2, giving you the Python 3 style function-based print syntax. Well, along those lines, you should try from dunder future import braces. The response is a syntax error with the explanation, not a chance. So somebody's having a little bit of fun. All told, there are 15 items in the list. And if you want a little entertainment, go check out the rest.
Yeah, I've heard people talk about the anti-gravity one a bunch.
Yes, there's a comic Easter egg built
XKCD.
in.
Yeah. And there's a few other ones I'd never had heard of. So there's a little more hiding in there than you thought.
Bored programmers with too much time on their hands. Yes.
Well, that brings us to the end of an episode. Thanks for bringing in all these articles and projects and discussion ideas.
My pleasure. Just before we close out, if you've written something interesting, there is a way to submit your content to the newsletter.
Yes.
We don't include everything, so don't take it personally that we get all sorts of stuff. But if you want a chance at it, feel free to submit stuff for us.
Yeah. And
we'll include a link to the forum in the notes.
I will, definitely. It's a good way to start the year. Get your projects and other things out there, and we'll see what we can include. Thanks again, Christopher.
Always a pleasure. See you in a couple weeks.
Okay. And don't forget, easy to start and scale, InfluxDB time series platform is available in the cloud, on premises, or locally. Get started for free today at influxdata.com. I want to thank Christopher Trudeau for coming on the show again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Paley, and look forward to talking to you soon.